Good day, learners. Welcome back to our mathematics class. In today's class, we want to look at a particular aspect of theory of logarithm. And this aspect is called change of base. Sometimes, logarithm can be given in which they are of different bases. Then how do we go about it? There are two methods that we can use in solving logarithm in which their bases are not the same. But before we proceed and venture properly into this, if you are just joining us for today and you have not subscribed, kindly subscribe to my channel and click the notification bell for my subsequent contents. And don't forget to share, like, and comment as we move on. So, let's move on. As I said, change of base could be done in two ways. The first method is introducing a neutral base for the two letters or for the two letters. Let's say, for instance, we have log n base b. We have log n base b. I can introduce a neutral base in this. So it's going to become log n base c over log of this b base c. But normally this b is in base. But I am removing that base now, introducing a neutral base, which will be common to the numerator and the denominator. I use this common base because I feel this is what's going to suit my calculation. So it doesn't have a specific method, but I feel, according to the understanding of mathematics, that this will make me to get to where I'm going, to get my final answer. That is first method. The second method is using the elements, using the letter in the given question as our base. Using the letter in the given question as what? As our base. Let's say, for instance, log c base b. I can make it this way. Log c to base of that c over log b to base c. Now, I am using this letter in this question to denote the base for both of them. What I know very well is, from what we have done so far in the theory of logarithm, is log of a number to the same number gives 1. So this one is 1 over log b to base c. So let us now look for the way of application of this. Example 1. Find the value of log 81 base square root of 3. Now, before we proceed properly, I want us to realize that out of the two methods I gave to you, the second method is mostly used in our calculations. Not that the first one cannot be used, but we mostly use the second one. We mostly encounter the second one. Log 81 base root 3 could be written as log 81. Let me put base 3. I want to use this 3 in this question as my base over log square root of 3 base 3. Because I know vividly that I can get 1 here. So log 81 could be written as 3 raised to the power 4. So 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81 to base 3 over log this square root of 3 means 3 raised to the power 1 over 2 to base 3. So this 4 comes here. So I have 4 log 3 base 3 over this one come here 1 over 2 log 3 base 3. Now here log 3 to base 3 cancel out 3 to base 3, and if you like, log 3 to base 3 will give us 1. So and 1 times 4 still remain 4. So we have 4 divided by 1 over 2, which means 4 divided by 1 over 2. This division sign is still the same thing here. So I now have 4 multiplied by these 2 will go up and 1 will come down. So 4 times 2 is 8. So 8 over 1 is still what? 8. Example 2. Calculate the value of log x base 2 if log 4 base x is equals to 1 over 2. What we want to calculate is this, log x base 2. But we are going to come from here, meaning we start solving from this place to this point. This is what we need. That is log 4 base x equals to 1 over 2. I can move this way. Log 4 can be written as 2 raised to power 2 base x is equals to 1 over 2. Let these 2 here come here. So I have 2 log 2 base x is equals to 1 over 2. Now, I want to eliminate these 2 by dividing both sides by 2. So log 2 base x over 2 is equals to 1 over 2 divided by 2 over 1. So instead of using this sign of division, I want to use the normal sign. So 2 cancel 2. Log 2 base x is equals to 1 over 2 times what? 1 over 2. So log 2 base x is equals to 1 over 4. So meaning that anywhere I see log 2 base x, I put what? 1 over 4. So don't forget, what we want to find is to find the value of what? Log x base 2. I can turn this log x to base 2 to be log 2 base x so that I can easily substitute to 1 over 4. This one will now equals to, let me use the change of base, log x. I want to make that x as my base to base x over this one, log 2 to base x. Now this is log 2 to base x, this is log 2 to base x. So anywhere I see log 2 to base x, I will put what? 1 over 4. So we now have log x base x is 1 over, this is 1 over 4, which means 1, this is sign of division, divided by 1 over 4. That is 1 times 4 over 1. So 4 times 1 we have 4, over 1 is what? 4. So this is how to go about this question. Don't forget to subscribe to my channel if you find this interesting, and share, then leave a comment. Example 3. Simplify the expression log 3 base 4 times log 4 base 3 plus log 32 base 2. When we look at this, it's easier for me to express this one in this form because this is multiplication. I can say log 3 to base of this 3 over log 4 to base 3, then times log 4 to base 3 plus log 32 can be written as 2 raised to power 5 base 2. And when we look at this, log 3 base 3 give me 1 over log 4 base 3 cancel log 4 base 3. So this is 1 plus this 5 will move here. I have 2 log 2 base 2. Sorry, 5 will move here. Now log 2 base 2 is what? 1. 1 times 5 is 5. 5 plus 1, 6. So final answer is 6. Example 4. Given that log 27 base 3 is equals to log 64 base 1 over 4 plus n log 1 over 81 base 3. Now let's look at this question now. This one is very simple. Log 27 can be written as 3 raised to power 3, then base 3 is equals to, in this case I have to do change of base for this. Change of base, log 64, let me say base 2. I'm introducing base 2 over log 1 over 4 base 2. On your own case, you can introduce base 4 and look at it if it will work, okay? Plus n log 1 over 81, isn't that saying 81 raised to power minus 1 base 3. So this 3 moves here. So we have 3 log 3 base 3 out there is equals to log 64 can be written as 2 raised to power 6 base 2 over log 1 over 4 it becomes 4 raised to power minus 1 base 2. then plus n log. This 81 can be written as 3 raised to the power 4. But that 4 multiplied by minus 1, minus 4, okay, base 3. Then we proceed. Log 3 base 3 is 1. 1 times 3, I have 3, is equals to, this 6 will move forward. I have 6 log 2 base 2 over this one log, this 4 can be written as 2 raised to the power 2. But now 2 multiplied by minus 1, I have minus 2 base 2. Then plus, now this minus 4 has to move forward. Okay? So minus 4 is coming here, minus and is plus, I have minus. 4 multiplied by n, 4n log 3 base 3. Now we proceed. 3 is equals to log 2 base 2 is 1. 1 times 6, I have 6, divided by minus 2 has to move forward, minus 2 log 2 base 2 out there, minus log 3 base 3 was what? 1. 1 times 4n, 4n. So now I have 3 is equals to 6 divided by log 2 base 2 is 1. 1 times minus 2, minus 2, minus 4n. So 2 here, 1, 2 here, 3. So I have 3 equals to minus sign is plus, minus 3 minus 4n. So take this here to come and meet its counterparts. So 3 plus 3 is equals to minus 4n. 3 plus 3, I have 6 equals to minus 4n. Since I need my n, I have to divide both sides by minus 4. 6 over minus 4 is equals to minus 4n over minus 4. So 4 cancel 4. 2 here, 2. 2 here, 3. So n is equals to minus 3 over 2. So the value of n equals to minus 3 over 2. So let's take one more example and we'll call it a day. This is going to be our last question for today. Example 5. Find without using tables the value of log 8 over 27 base 2 over 3 multiplied by log 10 base 1 over 100. Now, I want to express this one in brackets to this base. Log 8 can be written as 2 raised to the power 3 over 27, 3 raised to the power 3 base 2 over 3 times, let me do change of base here, log 10 to base 10 over log 1 over 100 to base 10. So I now have log, this one I have this 2 over 3, 2 over 3. Both of them have power of 3. Then base 2 over 3 times log 10 to base 10, we know that one is 1 over log, this 1 over 100 is 100 raised to the power minus 1 base 10. I move, let this 3 comes here, I have 3 log 2 over 3 base 2 over 3 multiplied by 1 over log 100 could be written as 10 raised to the power what? 10 raised to the power 2. 10 times 10, that is 100. That 2 multiplied by minus 1, minus 2 base 10. Are we together? Now, log of the same number will give us 1. So this one becomes 1. 1 times 3, I have 3. So I have 3 multiplied by 1 over, so this minus 2, we have to move forward. I have minus 2 log 10 base 10. So I have 3 times 1 over log 10 base 10 is 1. 1 times minus 2, minus 2. Finally, I have minus 3 times 1, 3 over 2. Or minus 1 whole number 1 over 2. So this is the method of solving change of base in theory of logarithms. So don't forget to subscribe to my channel before you leave this channel and click the notification bell for my subsequent content like this, and do share, like and leave a love emoji as you leave the channel. We meet in the next class. Thank you very much.